Hello, and welcome back to our data structures and algorithms series. In our previous video, we solved a common problem, the Fibonacci, calculating the Fibonacci of a number using recursion. In this video, I now want to throw the ball to your court. I want to challenge you to solve the challenge of the Tower of Hanoi using recursion. As you know, the Tower of Hanoi works in this way. It's actually a mathematical puzzle that was invented by a Frenchman called Lucas in 1883. It consists of three towers. Let's call this tower A, this tower B, and this tower C. And it also consists of a number of disks of different sizes. Now, the challenge is actually to move all these disks to tower number C. But there are two rules to it. You can only move one disk at a time. That's the first rule. And rule number two, you cannot place a bigger disk on top of a smaller disk. So the order has to be maintained at all times. The same order where the least size disk is always on top of a bigger disk. So those are the two rules to this challenge. Let's look at an example. For example, if you're given just two disks, an input of two disks, how will you get them to tower number C? So we'll call this disk 1 and this one disk 2. So if you have two disks, then you'll have to move the first disk here on top to tower number B. So this one will come here. So disk 1 to tower number B. Then disk 2 will come to tower number C, tower C, like that. Then after that, step number 3, you'll now take disk 1 from tower B all the way to tower C, and you'll have solved the challenge like that. I'm sorry, the disk number 2 is not big enough to show you that, but I hope you understand. So really, that's how simple it is if you just have two disks. And you'll solve it in just 3 steps. But if you have 3 disks, for example, it becomes even a bit more challenging. So if you have an input of 3, then this is how you're going to do it. You're going to move disk 1 from tower A to tower C. So that's the first move you're going to make, disk 1 to here. Then, of course, you're going to move the next disk, which is disk number 2, from tower A to tower B. So we're going to move this one to here. So that is disk 2. Then after that, we now are going to move disk 1, this one here, from tower, we're going to move it from tower C to tower B. So we're going to place it on disk 2 here. So right now, that is where we are, and those are just 3 steps. So let me clear this so that I can be able to draw. So far, we have disk 2 on the bottom there, and we have disk 1 there, just by using 3 steps. So the 4th step will be now, remember we are just moving the 3 disks. That is our input 3. So the 4th step will be to take disk number 3 to tower C. So we are having disk number 3 here. Then, as you might have guessed, we're going to take disk number 1 here to tower C. So we are going to have it there. Then after that, we are going to take this one. We are going to take this disk back to tower A. So that now, remember this is now empty because it does not have any disk. So we are going to have disk 2 on tower A, like that. So now this place is empty. So let me just clear that again. So what we have is we have disk 3 here at the very bottom. Let me just clear that so that it's a bit bigger. Then we have disk 1 on top of it. Then we have disk 3, disk 2. We have disk 2 here. So we are going now to move this disk here, disk number 1. We are going to move it here. Then we are going to move back this disk number 2. So we're going to move disk number 2 here. So now we're going to have a bigger disk here. Let's say it looks like that. Then the last step then will be to take this back here. And by that, we will have solved the puzzle. You see, those are quite many steps. Yeah, so it's a very interesting puzzle. And that's exactly what I want to throw your way. Remember to follow the 3 steps that we learned, which include finding the recursive function, finding the base case, and finding the unintended cases. Once you've solved this challenge, please share your solutions or questions or insights in the comment section below. Also, I'm putting some 3 more challenges on the description section below. So after you're done with this one, you can also try out those ones. Just as an encouragement, please remember that it's not very easy to solve these challenges, but you just have to keep exposing yourselves to it and enjoy the process. Really, it's not about the final results, but the process. Can you just enjoy the process and keep trying and trying and trying until you get it right? So they're not easy, but if you keep practicing, you'll become better every day and you'll be able to solve any puzzle that comes your way. So thank you so much, and see you in the next video where we are going to talk about the big O notation, how to analyze the time complexities of programs and also the space complexities. So see you then. Bye for now.